graph rational functions. So we're going to pull in some stuff here we've been doing. We're going to use symmetry. We're going to use the y-intercept, the x-intercepts or intercepts, and asymptotes or holes. So we've discussed vertical asymptotes and horizontal asymptotes to sketch the graph of a rational function. We're going to do this by hand using what we know algebraically and these pieces. The steps for doing it: we want to first determine if there's any symmetry. Then we can find the y-intercept pretty quickly by putting 0 in for x. We then find the x-intercepts. Now we're talking about rational functions. So the only way a rational function is equal to 0 is if the numerator is equal to 0. Then we can look for vertical asymptotes or holes. Is there a horizontal asymptote or not? And then we'll sketch what we know and plot some points between and beyond each x-intercept and vertical asymptote, and we'll be done. This is going to take a little bit of time. I've got 2 examples I'm going to do, but it does take a little bit of kind of working with. Okay, so let's get started. Okay, so example 1, use the 6-step strategy to sketch the graph of f of x is equal to 2x minus 1 over x minus 1. Okay, let's determine symmetry. And I've left us a lot of paper here because this does take some time. Okay, symmetry. Do we have y-axis symmetry? Okay. And is it symmetrical about the y-axis? Well, as we remember, what we want to do, here's our rational function. To find y-axis symmetry, we substitute x with negative x, and we see if we get the same equation. So here's my original. I put in negative x for x. And now I'm going to do I'm going to simplify it. This is negative 2x minus 1 over negative x minus 1. I will compare it with the original. I will see that they're not equal, so there is no y-axis symmetry. Do we have origin symmetry? Well, here is, and I'll remind you that even though this says f of x, it's often easier to do symmetry by replacing that with a y, so you can kind of do the manipulation with it and not carry around this entire thing. So I replace f of x with y. This is the original function. To find origin symmetry, I replace both y with negative y and x with negative x and see if I get the same thing. So left side is negative y, right side is negative 2x minus 1 divided by negative x minus 1. I'll multiply both sides by negative 1. Okay, so let's see here. All right, I'll multiply this by negative 1 over 1. That's negative 1. Okay, so that means I get 2x plus 1 over negative x minus 1, and no, they are not equal. So I have neither y-axis nor origin symmetry. That helps me when I think about sketching it. Do I have any symmetry that I can take advantage of? Okay, step 2, what's the y-intercept? That's usually one of the easiest things to find, the y-intercept. And of course, that's when x is equal to 0. Okay, so my function is f of x is equal to, I'm just going to copy my function down again, 2x minus 1 over x minus 1. What is f of 0? Well, that's 2 times 0 minus 1 over 0 minus 1, and that's equal to what? Negative 1 over negative 1. That's equal to 1. So I have a, let's make sure you can see the bottom of my paper. I sometimes forget about that. I have a y-intercept at the point 0, 1. Okay, continuing. This is why this is why you want it. It's got a fair amount of paper. As we work through this, it does take some paper. A little bit of space. I'm a big fan of space. Okay, how about x-intercept or intercepts? So step 3, the x-intercept or intercepts, and of course this is when y is equal to 0. Okay, so I know that f of x, my function is 2x minus 1 over x minus 1. The only time that this is 0, the only way this can be 0 is if the numerator is 0, because 0 divided by anything is 0. So my x-intercept or intercepts is focused on the numerator. Okay, 2x minus 1 is equal to 0, and of course this leads me to add 1 divided by 2, x equals a half. So I have one x-intercept, and it is at the point 1/2, 0. Okay, let's take a look at vertical asymptotes or holes. Okay, vertical asymptote, and we can have more than one, so vertical asymptotes or a hole or holes. Okay, and this is where, okay, as a reminder, this is my 0 in my denominator. We looked at our zeros in our denominator. Okay, so when is, okay, let's take a look. This is my function, f of x is equal to 2x minus 1 over x minus 1. My denominator tells me that x equals 1. This is simple, simplified, no common factors, is a vertical asymptote. I have no holes. I only have one number that cannot be part of the domain, only one. The number 1 is not in the domain. And in this case, 1 is a vertical asymptote. It is not a hole. Okay, how about horizontal asymptotes? Okay, or excuse me, horizontal asymptote, because you can only have up to 1. Okay, well, this is where we take the function. I'll rewrite it again. F of x equals 2x minus 1 over x minus 1, and we go to infinity. If we go to infinity, as x goes to infinity, okay, this gives us a 2x over an x. We're focusing on these leading terms. Taking infinity and subtracting 1 is infinity. Taking infinity down here and subtracting 1 is infinity. So as you go to infinity, this is what we're essentially looking at, and there's a common x. X is common. These are both same degree. And so we can factor this out, and we come up with 2. Okay, so y equals 2 is a horizontal asymptote. Now, I said it in words, but let's note it down. I said it, let's note it down here. The degree of the numerator equals the degree of the denominator, okay? And since they're equal, we just look at the leading coefficients. 2 over 1 is 2. Okay, so now, last step. Let's find ourselves some points, and then we're going to sketch what we know. So let's see here. We're going to do some points. And we have x here, and we have f of x is equal to 2x minus 1 over x minus 1. We want points between on either side of the vertical asymptote. Okay, well that's at vertical asymptotes at 1. So let's do a -2. Let's do a -1. Yes, between each x-intercept and asymptote. Between the intercept and the asymptotes. Okay? So let's see here. I'll do 3/4. I'll do 2, and I'll do 4. So let's look at the graph. Let's look at, whoops, boy, that's a terrible vertical line. Let's see if I can't freehand sketch a little better vertical line than that. Okay, so there's my graph, x and f of x. And what do we know? Okay, we know there's no symmetry. A y-intercept at 0, 1. So I'll come here to 1 and I'll put in a y-intercept. An x-intercept at 1/2, 0. So there's 1. There's my x-intercept right there. And I know that I have a vertical asymptote at 1. So here is a vertical asymptote at 1. And I have a horizontal asymptote at 2. So here is my horizontal asymptote. This is y equals 2. This one is x is equal to 1. So now we want to choose points that are to the left, in this case, to the left of the x-intercept, between the x-intercept and the vertical asymptote, and to the right of the vertical asymptote. Okay, so I chose -2 and -1. Those are to the left. I already know what 0 is. To the left of the x-intercept. I want to be between these two. That's why I chose 3/4. And then I want to be to the right of the x-intercept. Okay, let's go back to what step 6 said to clarify that, to make sure we're all on the same page. Sketch what you know. I just did. And then plot points between and beyond each intercept and vertical asymptote. So I'm focusing on the intercept and the vertical asymptote. Well, if I put 2 in here, I get, let's see, 5/3, 5/3. If I put -2 in here, I get 5/3. Okay, -1 goes in, out comes 3/2, and I've already done the math. 3/4 goes in, out comes -2, and these are points. 2 goes in, out comes, I think 3 comes in. Yes, 3? Is that right? I believe so, yes. And 4 goes in, out comes 7/3. So we're plotting some points again beyond the x-intercept, between the x-intercept and the vertical asymptote, and beyond the vertical asymptote. So -2 says 5/3. Well, that's less than 2. -1 says 3/2. Well, that's 1.5. 2, wait a second, 3/4 says -2. That's down here. 2 says 3. Okay, so this is 2, and that means that's 3. That's up here. And finally, 4 says 7/3. I'll put 4 here. 7/3 is 2 1/3. Is that correct? No. 1, 2, and 1/3. Yeah, so that's right along here. So the right side looks like it's pretty clear. This is coming in like this, and it's coming down like this, and it's doing that. Now, of course, we can't cross the vertical asymptote. We could cross this one, but it doesn't appear to be. Okay, if we look at the right side, well, it looks like it's coming down from above, and we could check that with another point closer to maybe 1.1, and then it's being shaped by the horizontal asymptote. So I'm betting that's our graph right there. Let's take a look in our graphing on our device and see if we get the same thing. Clear out of here. I have a fraction, and it's 2x minus 1 divided by x minus 1. And we'll let's go to zoom standard, And here comes that part. And you can see it looks very similar to this. There we go. That's what we have. Same. There's my horizontal asymptote at y equals 2. Here's the vertical asymptote at x equals 1. And you can see how the graph is being shaped by both of those. Okay, let's do another example. A couple of examples helps. I realize it's a little bit long, but that's kind of how this goes. I also, note I'm giving myself a lot of space for writing. This takes some space, and that's okay. Okay, let's use the 6-step strategy to sketch the graph of f of x equals 3x squared minus x squared, divided by x squared minus 4. Okay, so we're first looking for symmetry. And let's start out with y-axis symmetry. Okay, and we know our graph, we replaced the f of x with a y to make our life a little bit easier. And we have 3x squared divided by x squared minus 4. We replace our x's with negative x's, so 3 times negative x, the quantity squared. 3 times negative x squared. And then we have negative x squared minus 4. And that's the same, well, negative x squared is x squared. And so we can rewrite it like this. And same. Those two are equal. So it is symmetrical with respect to the y-axis. We don't even need to check the origin because there's nothing that's symmetrical with respect to both there's nothing that is symmetrical with respect to both except for the origin. Okay, so it is symmetrical, and this will help us to draw it. With respect to the y-axis. No need to check the origin, as I said. Okay, number 2, what's the y-intercept? Y-intercept, of course, is when x equals 0. I'm going to save space by writing off to the right. Okay, so f of 0 is equal to 3 times 0, the quantity squared, divided by 0 squared minus 4. But my squared a little bit better there. Well, that's 0 divided by negative 4, which is 0. So the y-intercept is at 0, 0. Y-intercept at the point 0, 0, which obviously means I have an x-intercept at the origin as well. Let's test that. The x-intercept, well, that's when y is equal to 0. Okay, so I'm going to come down below here. When does 3x squared, when is 3x squared divided by x squared minus 4 equal to 0? Now I have y equal to 0. Well, the only way it's going to be 0 is if the numerator is 0. So this tells me when is 3x squared equal to 0? Well, I solve this and I get x equals 0, but I knew that, okay? So the y-intercept, I put 0 in for x and solve it. I got a y-intercept at the origin. The x-intercept, I want to know when is a fraction equal to 0. The only time a fraction equals 0 is when the numerator is equal to 0. And so I have an x-intercept at the point 0, 0. Okay, sliding this up. These are some things now. I'm going a little bit quicker at times, but we've been doing x-intercepts and y-intercepts for some time. Do I have any vertical asymptotes or holes? So I'll abbreviate vertical asymptote or hole. Okay, and this is my 0 denominator. When is my denominator 0? Well, let's take a look. I have 3x squared divided by x squared minus 4. That's the same as 3x squared divided by, this is a difference of squares, so x minus 2 times x plus 2. And you can see there's no common factor. I have two zeros. Okay, I have two x values that are not part of the domain, +2 and -2. Okay, this is as simple as it gets. There's no simplifying my numerator, so both of these are vertical asymptotes. Okay, so -2, let me write that with x equals. X equals -2 and x equals +2 are not members of the domain. Okay, and as we see, because there's nothing to cancel them out in the numerator, both are vertical asymptotes. I've abbreviated that VA. X equals -2 and x equals +2. Okay, moving into horizontal asymptotes. Okay, with a horizontal asymptote, we look at the leading. So let's write down the function. F of x equals 3x squared divided by x squared minus 4. Okay, when we go to positive infinity and negative infinity, we're focused right here, the leading terms. Okay, we're focused on 3x squared over x squared because subtracting 4 from infinity has no meaning. And we notice we have the same degree numerator and denominator, so those would cancel each other out, and we're left with 3 over 1, which means y equals 3 is a horizontal asymptote. And of course, as we know, we can only have one horizontal asymptote. Okay, when the degree is the same, we can essentially cancel it out, and we're left with 3 over 1, which is 3. Okay, now let's plot some points. So I'll do that with number 6. Let's first sketch the graph. I've left myself a little bit of space here. Let's come over here and let's sketch what we know. And then we'll sketch a few points. So here's x, and here is f of x. Okay, what do we know? We know we have y-axis symmetry. So we're going to note that we're going to have symmetry about the y-axis. We have a y-intercept and an x-intercept at 0. So those are my two intercepts. I have a vertical asymptote at x equals +2. This is x equals 2. I have a vertical asymptote at x equals -2. This is x equals -2. And I have a horizontal asymptote at y is equal to 3. Okay, so that's what I know. Now I got to come up with what's this thing look like. So let's see here. I need to put in some other points. So how about f and then f of x, x and then f of x, and f of x is 3x squared divided by x squared minus 4. So let's take a look here as we plot some points. And we want points, we want to be between the vertical asymptotes and the x-intercept in this case and beyond, and see what's going on. So let's choose -3 because that's over here. Remember, this is -2. -3 goes in, and I haven't done it yet. My apologies. Let's see here. -3 squared is 9. It would be 27. -3 squared is 9 minus 4 is 5. Looks like that's going to be 5 and 2/5. So that's way up here somewhere. That's a point up there. Let's put in -1. This is 3 divided by -3, I think. 1 minus 4, 3. This is -1. So -1 is here. Okay. -1, -1. Let's put in positive 1, because that's between these 2 points. And I could probably plot some more points, would help me with understanding this part. Let's put in positive 1. Again, this is positive 2. This is 3 over negative 3. That's also negative 1. Well, that makes sense. We know we have y-axis symmetry. So I'm guessing this part is going to look like that. That's my guess, okay? We have the origin. This is symmetrical. This is a vertical asymptote. That's that piece. Let's put in positive 3, and I'll have the same thing. I'll have 27, I believe, yes, 27 over 5. So positive 3 is, again, 5 and 2/5. So that's going to be up here somehow. So I'm not positive how this top part looks. I'm feeling pretty good. I might want to do some more points, but I do know this is a vertical asymptote. This graph is coming like this because of the horizontal asymptote and because of the symmetry. I could put some additional points in to see what's negative 2.1 and where does that get me. What's positive 2.1? It's up higher up here. I just chose those 4 to give me some points. And then I have a sense that this should be symmetrical. So my graph looks like it's going to look like that. It would be my guess. Okay. Again, I probably could put some more points in here, but I have enough experience to kind of get a sense of this. Let's see. Okay, y equals, and let's clear this out and go back into here, and I know I'm doing 3x squared divided by x squared minus 4. And let's go to zoom my standard window again, and let's see what's happening. So there we go. I got the top corners correct. There's that middle piece, and there's that right upper corner there. So you can see very similar to here, what I was kind of sketching out, a little bit less room, but you can see how the vertical asymptotes and the horizontal asymptote are shaping how that looks on the left and right. And you can see the the y-axis symmetry going through there. Okay, that's a lot of video on that topic. It takes a little bit of time, so take your time and certainly make use of your graphing device here and there to see if you're on the right track.